Okay, so the question here is whose time gets dilated if you are in a situation where one person is moving fast enough to experience time at a different rate than a different person. This is known as time dilation. A couple of videos ago I actually talked about it, but the answer to whose time gets dilated is neither. Hello, my name is Zeta. This is my physics degree. Let's talk about it. So there are two really important points to think about when we try to contemplate whose time is being dilated and who's in the correct time. The first is that, relatively speaking, all frames of reference are equally valid. The other is that light will always move at the same speed, regardless of the speed of the source. Let's start with the first one. So the idea that all frames of reference are equally valid is something that you might have learned if you took a high school physics class. You might, somewhere in your brain, recall the idea of relative velocities. So what that means is that if a car is passing by, it's going 20 miles an hour. That would make sense for my street. It's not super slow. It's moving by at 20 miles an hour. I can observe that car moving at 20 miles an hour. That car can also say, I am moving at 20 miles an hour, but it is stationary. Right? Because even though we think of the car as the thing that is moving while I'm just sitting here, I, from the perspective of the car, am what is moving. And both of those are equally valid, and you can make that claim about anything in the universe. A particle in my hand is equally valid as a particle in a quark star in another galaxy. You can observe things moving from either point. Mathematically, they will be equivalent, even if they look different, which means that each one is equally valid and equally correct. The second really important point that I mentioned is that light will always move at the same speed regardless of the relative speed of the source. This is where the universe starts looking like a, shall we say, big ball of wibbly wobbly, timey-wimey stuff. So what we would normally expect if, say, that car is moving by at the 20 miles an hour, someone throws a ball, I'll see the ball also moving at 20 miles an hour. Because they're moving with the ball, they won't see it moving in the horizontal at all. That is the relative velocity idea that you would have learned in your high school physics class if you took one. When we start getting into ideas like time dilation and special relativity, we need to think about things differently because light is special. So light will always move at the same speed regardless of the speed of its source, means that a spaceship heading toward you at half the speed of light, turning on its headlights, will see the light moving away from itself at the speed of light, so 3 times 10 to the 8 meters per second-ish. You will also see that light moving toward you at the same speed, even though you are at different speeds relative to each other. You wouldn't be able to observe each other as stationary, but you would see that light moving between you at the same rate, which means both equally valid viewpoints are experiencing light at a different rate in a different way, and light is directly linked to how we progress through time within the universe as far as we understand it. So if both frames of reference, both the fast-moving and the still, are experiencing that light in different ways, and therefore also experiencing time in different ways, both are equally valid, both time frames are equally valid, both ways to progress through time are equally correct. I will say the way that my physics textbook explained time dilation to me, it sounded like the moving object was the thing being dilated, but again, remember, both viewpoints are equally valid. We can assume that the moving thing is now stationary and the thing that we thought was stationary is now the thing that is moving, and both are correct, which means both time frames are both changed and original. So the short answer is neither. The long answer you just got. To neither time frame is technically dilated, even though they are different because they're both equally valid. Thank you, Albert Einstein and your relativity theories, for making the universe confusing.